Welcome to A.S.K Thermal Tutor. In today's topic, we are going to discuss regarding vapor power cycle. As the name itself indicates, here the working fluid in the cycle is a vapor, and how this vapor is created. This is generated actually by heating a water at particular pressure. It is heated to high temperature so that the water is being converted into vapor. So generated high pressure and high temperature vapor, or what we say as steam, is sent to the steam turbine. Basically, here after heating in the boiler, it is sent to the steam turbine, and when the steam goes to the steam turbine, the high pressure and high temperature steam starts expanding in the turbine, and finally the pressure and temperature drops in the turbine, and this turbine in turn gives the work, and this work can be used for the various purposes, and we are not concerned with where the work is being used, just we are concerned with about the work output here. Okay, so after expansion in the turbine, the steam goes to the condenser where it is being cooled. In the condenser, for the purpose of the cooling, a cooling medium is used. It might be a cooling water or something else. Usually it will be a cooling water. Okay. After cooling in the condenser, the steam is converted into water. Here again you can see the medium has been changed from gaseous phase to liquid phase, that is water in the condenser, and from the condenser the water is pumped by using a pump to the boiler, and again in the boiler the cycle repeats. That means again it is heated to the steam, and the steam so generated is passed to the steam turbine, and the cycle repeats. This is how the cycle is. Okay, and here we are concerned with how this cycle is being operated, and we are going to study about various cycles related to it, and most specifically we are studying in this unit is the Rankine cycle. Good morning, my dear friends. Today we shall start the topic of vapor power cycle. Firstly, let me explain what are the components which is associated with the steam power plant. See, as I have told you, it consists of the four main components. One is boiler, turbine, condenser, and pump. See, in boiler, water is heated to its vapor state, that is what we say as the steam, is sent to the turbine, where in the turbine the steam expands, so that after expansion the pressure here at the exit of the turbine is less, also the temperature drops. After expansion it goes into the condenser. Remember, still the state of the steam at the exit of the turbine, it is in the vapor state. Okay, usually it will be a mixture of vapor and liquid water. So as we go into the topic you will understand. Okay, then it goes to the condenser where it is cold in the condenser, where in the condenser it is cold, the steam is condensed, as the name itself indicates, it is a condenser. So the vapor form of the steam is totally condensed in the condenser, and the liquid water is pumped by using a pump back to the boiler. This is how the process takes place in a steam power plant. Okay, here if I say Q1 is heat supplied in boiler, WT is work done by turbine, Q2 is heat rejected in condenser, WP is pump work. Then from basics of thermodynamics we know that cyclic integral of heat supplied is always equal to cyclic integral of work done, that is summation Q is equal to summation work. So here I can say that Q1 minus Q2 is equal to WT minus WP. Here Q1 is positive because heat is supplied to the system. This is positive. And Q2 is negative because heat is rejected from the system. See the sign you need to note here. Okay, so that's why I have used Q1 as positive and Q2 as negative. When I take turbine work, it is work done by the system. We know from the basics of thermodynamics, work done by the system is positive. So WT is positive. And coming to the pump work, WP, it is negative. Work done on the system is negative, so it is negative. So we can now say that net work done is equal to net heat supplied in a cycle. We know that from basics of thermodynamics. Then if I say what is its efficiency, see efficiency expression is always, we know that it is output by input. Here output is the net work done, input is the heat supplied. So in the system, which is the input we are using the heat supplied as the input. Okay, this is the only heat input input to the system. When I take turbine work, the part of the turbine work is used to run the pump. So only Q1 is the input. So this is the input Q1 and this is the output. Why it is Q net? Because it is turbine work minus pump work. I need to subtract the pump work from the turbine work which I am getting. So your efficiency is this one finally. Okay, turbine work minus pump work divided by Q1. Q1 is the heat supply. So for a steam turbine, the general expression of efficiency is net work done divided by heat supplied. So this thing you need to note.